collaborator and I started talking during COVID about the problems that exist in communications technologies, such as the one that we're using, Zoom, that they don't provide a level of feedback, and we thought that is helpful. Like the video is good, and most people I don't think really use it. And the audio, together they're not really that good. Like the latency compared to like a telephone call is pretty substantial. So it causes all this weird stuff, especially like looking at yourself talking is kind of detrimental. I started talking to him about what can we do with the voice, what can we do with the face to help inform the speaker about how they're being perceived by the project here is one specific part of that, which is looking at faces, assuming that you have the video. We started from looking at skin tone. My collaborator wanted to see if we could estimate skin tone because it was something he was doing for in his work. We're taking images and we are applying a segmentation mask to them, which is trained using a UNet architecture. It's a UNet with a ResNet 34 backbone. And it is that provides when you give it a face as an input, it tells you what's the skin. What's yellow is like the general skin, and then the nose is like the bright yellow here. And so the inaccuracy we see here in the UNet, you got the lips and the eyes, and then there's a layer that I wrote on top of that which separates out direction. Typically what is done is they take in images, they take a 50 by 50 pixel square from the cheek. And so we wanted to do left and right cheek, and forehead also seemed like it might be a good place to sample skin tone, and the nose. The second feature, in addition to the skin tone that's built on the segmentation mask, is the facial width to height ratio, which is in the literature has been used. It's sexually dimorphic, so it differs between genders quite a bit. And also we thought maybe like men who have like more faces that have facial width to height ratios that are typically associated with females. All of this is pretty controversial to talk about. I don't know, which is fine. The model itself, this sort of breaks it down. I'm using the Fast AI framework, which I'm a true believer in. Basically, it's just the most awesome thing ever. So so the process here I've been scrolling through, which is probably pretty irritating. This is the data set. The data set's called Mutiny Face, and then so this is the test image. And so I just ran through and just did a little basic sort of training. It took 24 hours because the UNet takes longer. It's pixel level labeling instead of just a single label for one photo. But I trained it for 24 hours and then looked at it. I was like, oh, well, this is the out of bag sampling here, which is like, the model didn't see these images, and I just visualized them real quick, and I was like, oh, that worked pretty good. And I was like floored, actually, that it worked so well out of the box. And then I just started applying it to to our sample images. I looked here at sort of this is what the segmentation mask looks like, sort of in its rawest form. You see there's no cheeks or indication of right versus left or forehead or. And then this is it after filtering out a confidence threshold. If the observation or the prediction wasn't more than 99% confident, then I filtered it out. So it was interesting to see that the model is less confident about the edges of this guy, the edges of the regions, I guess, the edges, like completely wiped out the eyes, I think, except for maybe a little bit right there. Yeah, anyway, so we dug into that a little bit. The initial objective was just this, where we had my colleagues sampled the right cheek and left cheek from his data set for skin tone using Photoshop. And so and then we compared the nose prediction to those, and it's pretty close. And then the left cheek is really, I think, really close, like almost visually impossible to tell whether or not tell the difference between the left cheek and the left cheek. And then also the right cheek and right cheek are very so like. What was exciting about just looking at this at an anecdotal level, like example by example, is that the left cheek is closer to the left cheek and the right cheek is closer to the right cheek than they are from each other. So like visually you can see the difference. So yeah, I think this is a work in progress, and we been working with facial recognition.